Alright, motor encoders. You can see that this was a kind of a long bit of code and it wasn't that reliable. So we're gonna sort the first problem out of being reliable in terms of using motor encoders. Now I give you a whole bunch of values here, and let me first explain kind of how to get motor encoders started. So the first thing that you'll need to do is have your motor, and you need to basically tell it to stop and reset its encoder, because if you've been running it for a while, then that encoder tick, which is essentially how many times the wheel has moved, has been incrementing this entire time. And so whenever you start the program, you want to make sure that it's reset back to 0, so you're not basically keeping the old value of whenever you're running. So first we'll need to stop and reset, and then what we need to do is set its target position to 0, which it's been reset to. And then what we'll need to do is we can actually do a few things here. Now, the one that we'll be using is run to position, which is incredibly useful and pretty much automatic. Because at this point, all that you need to do is just set the power to 1, and then set the target position to whatever, and it'll just head to that target position. But what do you put for a target position? Again, I gave you all these values here, and you'll need to do a bit of math here to kind of figure out what you'll need to put here. Because for every full 1 revolution of that wheel, it will have 560 ticks incremented. And the wheel circumference is 4 pi inches, because the diameter is 4 inches and the circumference is the diameter times pi. So if you kind of think about it, you can see that if you have 1 full rotation of the wheel, that may move the same amount of inches of the circumference of the wheel, if you kind of think about it in that way. So I encourage you to kind of first think about the math. So you kind of want to get into a system of being able to input just an amount of inches and then being able to get a target position, because we can't really understand a target position, but we can understand going forward by inches a lot better. And just to kind of let you know that each of these tiles are about 24 inches in size. So if you try and travel here, that would be 1 tile, 2 tile, 3 tiles. That would be about 6 feet or 72 inches that you would need to travel to get to there. Alright, one other quick thing that you need to know for using motor encoders is that you're no longer using timing. And then the program essentially won't know when to move on to the next target position that you want to call to it. And so then that's whenever you kind of use the .isBusy function. That .isBusy is basically asking the motor if it's busy or not, which will return true if it's trying to get to a target position, and return false if it's reached its target position. And then you can imagine using maybe another loop, maybe a while loop. Well, while this front left motor is busy and it's trying to get to its target position, stay in this loop, and then after that it'll move on to the next code of execution, which would be setting a new target position for the motors to go to. So that was a lot of information. I encourage you to kind of write it down, as I sometimes do if I'm loaded with a lot of information and I'm trying to solve a problem, and see if you can think of some type of system of going and delivering the second wobble goal here.